Hello friends, a problem is here given in which two charge pairs are suspended by massless strings from a common point while the length of string is L and the spheres are initially separated by some distance d due to their mutual repulsion. What happens? These two spheres start losing charge at a constant rate, and by virtue of that they will try to come closer to each other at every movement. So this distance will reduce and they will move with some velocity. So we are asked here to find the relation between the velocity of these spheres and the distance they are separated by. Now let us solve this. Here's a free body diagram of the system. You can see the system is symmetric. The forces on this sphere will be same that on this sphere. Now let us represent the forces on this sphere. Three kinds of forces act on this sphere. One is the tension force, due to the tension in the string, T. Another is due to the mass of the sphere, mg, that's gravitational force. And another force is due to the mutual repulsion, Fe. If we resolve this tension force by virtue of this theta, which is angle between this line separating passing through the center of the system, since this theta and this theta will be same, we can resolve the tension force in two components, t cos theta and t sin theta. It makes our problem simpler. Now we can calculate forces on two axes, x-axis and y-axis. The forces along x-axis are t sin theta minus Fe equal to 0, and the forces on y-axis are t cos theta minus mg equal to 0. If we simplify this, t sin theta is equal to Fe and t cos theta is equal to mg. If we divide this equation by this, we get sin theta over cos theta equal to Fe over mg, or tan theta equal to Fe over mg. Guys, in this problem, it is also given that the length of the string is much bigger than the distance the spheres are separated by. We are calculating equations at some instant where spheres are losing charge and they are separated by distance x. If we see these spheres are suspended by constant length string L, they will try to move along the periphery of a circle. Since L is much bigger than x, this x will approximate a straight line. And there's a relation between theta and arc length on the circle. You can see here the diagram at the theta making some arc here, L, is given as theta equal to L arc length over radius of the circle. In this case, the theta here is 2 theta. 2 theta will be arc length, that is x, over radius of this is L, or we can say theta is equal to x over 2L. When theta is much small, that is when this length is bigger than this length, we can write tan theta equal to theta. Tan theta approximates theta. So we can write this equation theta equal to Fe over mg. Guys, the force Fe between these spheres at any instant while they are separated by some distance x can be written as Fe equal to K electrostatic constant, Q square, charge on two spheres, over distance square. So theta can be written as K Q square over x square, and there is term mg. And we know the value of theta, so x over 2L is equal to KQ square over mg x square. So we got x by 2L equal to KQ square over mg x square. Now, if you observe in this equation, only two quantities are variable, that is x and q. The charge is being leaked and distance is reduced between them. So we can write it x cube. All other terms are constant, is proportional to q square, or q square is proportional to x cube, or q is proportional to x power 3 by 2. We are going to find relation between v and x, that is velocity and distance. So we can differentiate this equation with respect to time to get equation of velocity. T by 2 x power 1 by 2 dx over dt. This term is constant because charge is being leaked at every moment at a constant rate. So we get here, this is also constant. We can write it as x power 1 over 2 times v. Here is this term is constant, we can write it as c dash. Or we can write v is proportional to x power minus 1 by 2. So the velocity with which these two spheres are approaching each other when they start losing charge can be given as proportional to distance power minus 1 by 2. Hope you understand it. Thank you.